into the second last Aspire webinar session for Graduate Aspire 2021. So make sure you make the most out of this session by asking the panelists as many questions as you would like to in order to extract as many knowledge as possible. My name is Dania from Graduate's content team. And for this session, we have two representatives from UMobile who will be sharing all things data science, how you can get started, and wield this superpower. Allow me to introduce them. First, we have the speaker, Kamra Jamakan, the Senior Manager of Data Science and Customer Value Management at UMobile. And we also have Teresa Lee, who will be moderating a quiz session. In this session, Kamra will go through her career path into data science and explains what a data scientist does. And she will also explain the cool machine learning use cases and what a real life intern did at UMobile and many more. So make sure you tune in until the end of the session to find out. And for your information, Team Graduate is giving away 5 Shopee vouchers for every webinar session. So to those who are watching, you are highly recommended and encouraged to drop your questions in the chat box, as those who had the questions picked will win the vouchers. And make sure to follow us on our social media, Graduan, for more updates on the latest happenings in the Graduan universe. Now I'll be passing the floor to Teresa for the quiz sessions. All the best.
Okay, guys, so we're going to start with a bit of a quiz so I can get to know you and maybe what you think of data science. So there is a quiz going on, so you can see from the screen. Slido, you can join at slido.com of number 429958, or you can scan the QR code at the top. And we are going to start with this first question. So please join the Slido. Is data science still sexy? Yes, maybe, no, or don't have an opinion on this. Yeah, please send your thoughts. I'd like to know what you guys think. Okay, well, this is pretty cool. So around 70% of you think data science is still sexy. About 20% of you don't have an opinion, and 70% of you are like, maybe. That's good. Okay, so we're going to talk a lot more about this later. Teresa, can we have the second question, please? Okay, so now a different kind of question. What adjective would you use to describe data scientists? So, you know, what do you think data scientists do? What do you think their personality is like, maybe? So what's the one adjective, or maybe a few adjectives, you would like to use to describe data scientists? Ooh, okay, I see innovation. Yes, that's true. We're normally on, you know, the cutting edge of technology. Analytical, yes. We deal with a lot of data and a lot of analytics. Logical, yes. We have to be very logical with our thinking. Money, I guess, yes. We normally are involved with use cases that make money. Python and SQL, yes, very good, whoever put that. That is indeed very important for data science. Statistics, numbers, critical thinking, intelligence, okay, genius, okay, cool. So that's great. So I guess you guys do know a little bit about data science. Okay, I see painful as well, sometimes it is, yes. So let's go on to the next question. Okay, now, just to know from the audience what you guys think. Are you guys interested in becoming a data scientist? Okay, the yes just blew up. Okay, the maybe is there as well. Okay, so I guess that's good. We have people here who are interested in learning to be a data scientist. Okay, some people don't, that's fine as well. Maybe you just want to listen and, you know, see what the technology trends are. Some people are confused, but okay, this is pretty good. So most of you guys are yes and maybes. Perfect. Okay, so now I am going to start sharing my screen. Okay, so just give me a second. Okay, I'm assuming everyone can see that. Okay. Teresa, is the screen fine?
Camera, you may want to enlarge it full size.
This is the full size at the moment.
Okay, then we can just carry on. Good
Okay,
job.
hold on. Let me just try again. So let me share my screen, and let's go to the window, and let me share the sound as well because we have some audio coming later. Okay. So you're able to view this, I suppose. If not, someone let me know.
Yeah, we are able to view.
Okay, that's great. So, good afternoon, everyone. My name is Kamra, and I work in the Data Science and Customer Value Management team at UMobile. Today, I will be presenting a talk, Data Science, How Can I Get Started and Wield the Superpower? So this talk will start with my career path to data science. Part 1 will cover some data science basics, and in part 2, we are going to talk about machine learning. For part 3, we're going to look at some cool artificial intelligence use case with the creative arts. And in part 4, I will show you what an intern learned during an internship with UMobile. Finally, we will end with some useful resources for aspiring data scientists, and then a quiz to check if you were listening. And don't worry, we're going to keep this light on the technicals and focus more on data science and the interesting things you can do with data science. So let's begin. Okay, so we're going to talk a bit about my career path to data science. And you can see the left-hand side is a picture of me with my final year project doing biomedical engineering at university. This was a few years back, and I was probably around the same age as you guys are now. And I had no idea what I really wanted to be or do with my life. On the right-hand side is me now, a senior data scientist at UMobile. So how did I get here? So basically, a series of happy accidents and a love of learning led me to where I am today. I guess the journey started at university, doing biomedical engineering. If you don't know what biomedical engineering is, it's basically a mixture of medicine and engineering with many subjects you have to learn. This is probably where I was first really exposed to computer science. And I remember struggling a lot with it at first and memorizing code for my C exams. But I came out of it all right, and I ended up really enjoying maths, computer science, and the logical aspects of my degree. Afterwards, I wanted to work, and everyone needs people who can do numbers and coding, including professional football betting, which is something I knew absolutely nothing about. And I ended up working for a sports betting company that needed quantitative analysts to help crunch numbers and build statistical models for football betting. And sports betting was a pretty fun industry to be in. And within this company, I worked with some quants from Hong Kong that came from financial engineering backgrounds. This led me to pursue a master's in financial engineering. And after my master's, I worked for a bank for a bit, doing things like building models to price exotic options and validating numbers for systems. And at first, I thought quantitative finance was my dream job. But eventually, I grew bored and started playing around a lot with technology, including building my own Android apps and participating in hackathons. I then won a prize in an RHB hackathon and started working for RHB as a data scientist. I also ended up working as a prototyping engineer, where I would build proof of concepts quickly for cloud. And if you do have a good understanding of technology and how apps are built and how websites are built and how information is collected, this also makes you a better data scientist, as you better understand the flow of information and how it gets to you. And all this is fun, but then I realized banking was getting a little bit boring for me, and I wanted to explore other industries. So now I'm a senior data scientist at UMobile. And when you look at this, right, this is my convoluted career path. When I first started out, data science was not what it is today, and there wasn't as much technology or data. But you can skip all these steps in my path and apply straight to the U Mobile Apprentice program. So stay tuned for more details on that. Okay, so I do want to go into the turning point of my journey a bit more, because this is really where I decided I wanted to be in technology and data science. And I did and explored a lot of things at this stage. And in my free time during this period, I started teaching myself Android development and going to a lot of hackathons and winning. So what is a hackathon? Well, a hackathon is a combination of hacking and a marathon. And it's an event which a large number of people meet to engage in collaborative computer programming and basically build something very cool in a very short period of time. And hackathons are great because it's very collaborative and you learn a lot of different things from people with different backgrounds, and you have to build prototypes fast. And just to be clear, when I say hacking in this presentation, I am referring to programming and coding, not to gaining unauthorized entry to computer systems. During this turning point, I also did some Android developer courses at Magic in Cyberjaya and Udacity nanodegrees in deep learning and artificial intelligence. As I grew more confident with my abilities, I also started helping out with the local developer community. I did talks, ran code labs, and helped out for both Google Developer Group KL and Women Tech Makers KL. If you guys are not members of these groups, join now. Whether you want to do data science or software engineering, digital marketing, or basically anything to do with technology, being members of these groups and having a community really helps. And I like giving talks because I like exploring technology and sharing about it. And if you haven't done this before, try giving talks on technical subjects that you know well, because you will really understand your technical subject areas when you force yourself to give talks on the subject. So most hackathons are free. And as you can see from the photographs, you can win some money. Not that it's about the money. How much you learn is way more valuable. And for me, I like the street cred. Also, joining developer communities are free. All you have to do is click like and start following on Facebook. So for me, most of these resources are free and there is no risk and everything to gain. So if you're thinking about it, why not just try new things? So now we move on to what is data science? Okay. So data science is an interdisciplinary field that uses scientific methods, processes, and algorithms to extract data insights. So this is akin to making discoveries while swimming in data and trying not to drown in data. And on the right, you can see a Venn diagram showing typical skills needed of a data scientist. And from here, you can see you need hacking skills and some programming knowledge, because data these days is electronic. So you need to speak hacker. You need to be able to code because data is unstructured and present in unusual formats, and you need to be able to handle this. You also need to be able to program to apply statistics to problems and handle databases. Hacking also helps you work with different algorithms to manipulate the data and get the best results. You also need some domain knowledge. Here it's called substantive expertise, right? And this is knowledge of the field the data belongs to. You need this to understand the problem of what you are applying data science to. You also need some math skills, because if you have the other two skills like hacking and the domain knowledge, but not the math skills, you end up in the danger zone. Because you may think you are programming something to solve your business problem, but if you don't understand the maths behind it, you may end up programming something you don't actually want. There's also a science process diagram on the bottom left, which shows how we come up with experiments from hypothesis as well. So with respect to the science part, a data scientist takes a set of data develops a use case for that data, and creates a hypothesis on how to make use of it. They may perform experiments using the developed hypothesis, analyze the results, and come up with a solution. And we can go back and forth between these processes, tweaking the analysis or getting more data and adjusting the hypothesis. Okay, so look around at the headlines and you can see in all the newspaper cuttings, data scientist, sexiest job of the 21st century. And data being the new gold seems to somehow make data science sexy. 10 years ago, mathematicians and programmers were nerds. Even worse if you were programming mathematics. Now, this is a sexy new field. Well, why is data science so sexy and exciting? And what is the hype with this thing called data science? Well, there have been some recent developments. Number one, these days with smartphones, Internet of Things, etc., we have more data because there are more people and more devices and therefore more data in the world today. The volume of data is surpassing human ability to make sense of it all and write rules. So we turn to automated systems to learn from data. We also have better hardware and better compute. By this, I am referring to processes that train and serve your machine learning models. One example is graphical processing units, or GPUs, which were originally built for video gaming. Experts then discovered that GPUs can train deep learning networks much faster than CPUs. We have better developed open source tools as well that people can use for free, like TensorFlow by Google, which provide people easy ways of building and deploying machine learning. There's also been some breakthroughs in algorithms. So in 2015, we had an ImageNet challenge where both Google and Microsoft beat humans at image recognition, identifying objects from over 1,000 categories. And in 2016, we had a program called AlphaGo Zero, which beat the Go world champion Lee Sedol 4-1 games. So what skills does a data scientist need? Well, as mentioned from the Venn diagram earlier, you do require strong foundations in maths and programming. So in maths, you need to know about statistics and about probability. You also need to be good at calculus because derivatives are important in machine learning algorithms. You also need to know linear algebra, as data is normally in a big matrix form, and you need to know about matrix manipulation. For the programming side, you need to know statistical languages. Primarily these days it's Python, but also R. And it's also good to know database querying languages like SQL. Shell scripting is also good to know because sometimes you need to quickly process large data and files quickly, extract data from other servers, or automate processes from a pipeline. Machine learning. It helps to know your machine learning algorithms and have working knowledge of machine learning libraries like scikit-learn and TensorFlow. And after doing all the analysis and building the models, you need to be able to tell a story of what you have done by using data visualization. And it's important to provide these visualizations to end users who maybe cannot use Python. Key visualization tools you may find useful for this are Google Data Studio, Power BI, and Tableau. Finally, the model you build is not that useful if you just keep it within a notebook. So you need software engineering skills to build pipelines or deploy your model so people who are not data scientists can use it and get results. So you can see on my screen, there's some screenshots of Jupyter Notebook over here, but I'm going to show you proper Jupyter Notebook. So give me a second and let me go to the next tab. Okay, so this is an example of a Jupyter Notebook. And how you should think about this is imagine it as a virtual book, right? Where you can write your thoughts, your theories, you can put images, and you can put your questions in it. And you can also execute code, Python code and other languages to prove your theories. So at the top, we see pictures that we are going to use and the output we are going to have. And below this, below all the pictures, you will see, we have some text explaining what we're going to do. And below this here, there's some code that we can run. So Jupyter Notebooks for data science is extremely convenient way for us to run Python, run code, and have all our ideas in one place. Okay, so now let's go back to the slides. Okay, so you can see from the diagram here on this slide that data science encompasses a lot of things, from data collection to feature engineering, machine learning, visualization, and deployment. The key superpower, and I guess the exciting part of data science, is machine learning, which is in red. And we will talk about this more later. But in reality, you will not just be doing machine learning, but almost everything to do with data. So all the green parts, including perhaps the not so glamorous parts like cleaning up data extracted from legacy systems. Now, let's talk about the dark side of data science. So data is not perfect in real life. On certain platforms like Kaggle or Colab, you may get really good results from running a model which already uses data that is already pretty clean. In real life, you can get a lot of dirty and messy data, especially from legacy systems. A lot of your time will be spent wrangling with data that is not correctly formatted and cleaning things up. Almost 90% of your time will be spent on data wrangling. Before you even start programming machine learning models, you need to do a lot of statistical exploration to understand data. For example, looking at distributions of data and feature engineering. In terms of time spent, building machine learning models is probably something you will spend the least time on, and most of your time will be spent on data wrangling. Most companies also can't afford to hire someone just to focus on being a machine learning engineer. And in most cases, you will have to know all of the skills in the pipeline on the previous slide. This can be overwhelming, but it also makes you a better and more competent data scientist. You also have to learn a lot. As I said earlier, data science is an interdisciplinary field where you need to know math, science, programming, as well as have domain expertise and business knowledge. Roles tend to be full stack, and you need to be pretty self-reliant on yourself to be able to help yourself to data from any server or mine logs when needed. For deployment of models and MLOps, you also need a lot of technical skills to do this, as your model is relatively useless if it just stays in the Jupyter Notebook. Okay, so let's talk about the sexy machine learning and artificial intelligence. Okay, so what is machine learning? Well, machine learning is when computers improve at a task based on experience without explicit programming. And the key feature of machine learning is learning from data. So on the left-hand side, you can see an old school comic, right? And you can see some instructions. She's trying to write a program to describe a fork. But to describe every single type of fork in the world, you would probably need an infinite number of rules to program. That's why we need machine learning for this use case, as machine learning is powered by data, not instructions, and learns from experience. This data-centric approach makes it good for learning by example, finding patterns in data, and predicting outcomes. So you can just give the model a lot of fork pictures and it will be able to figure out what's a fork or not a fork. And let's talk a little bit about the intuition. And I like using comics because I know machine learning, sometimes it can be a bit dry. So if you look at the comic on the right-hand side, in machine learning, inputs flow forward based on available data. And at the end, it produces an error. That is how far the algorithm was off from the actual answer. And this error difference is then fed back in through the model to retune the parameters. The inputs then flow through the adjusted parameters back and forth. And the algorithm is able to tweak and adjust itself as it goes back and forth and finds its own ways to minimize errors to correctness. So that's some intuition about machine learning. And now we're going to talk about artificial intelligence, AI, and its subsets. So AI is a broad field that encompasses any technique that enables computers to mimic human intelligence. And AI is based on the principle that human intelligence can be defined in a way that a machine can easily mimic it. And what do I mean by human intelligence? Human intelligence is not just programming the computer to drive a car by obeying traffic signals, but it's also when the program also learns to exhibit the signs of human-like road rage. Formally, machine learning is a subset of artificial intelligence, and machine learning is defined as a program or system that builds a predictive model from input data. The system uses models that learn from data to make useful predictions from new, never before seen data. A key feature of ML is the machines use algorithms to build systems that have the ability to automatically learn and improve from experiences without being explicitly programmed. Deep learning is a subfield of machine learning and AI that is inspired by working of neurons in the human brain and involves learning from examples. And we will look at some really cool examples of this in a bit. So officially, all of these terms, artificial intelligence, machine learning, deep learning, are a bit different. But for the purpose of this presentation, we will use these terms interchangeably. And now, how do we use AI in our everyday lives? Well, imagine Google search. You search for something and then somehow magically, most of the time, you get back the right thing with the right context. For example, if I search for Java in my Google search results, the results will be related to Java, the programming language. But for my friend who loves coffee, it might direct them to Java coffee beans. Another example is YouTube's recommendation system for the next video to watch. And then we also have how Facebook or Google Photos seems to know who to tag in your photo. So you can see from my current career path that I've tried a few things and I've been through a few industries. And let me tell you, if you intend on having a career in data, being at a telco is the best. And it's the best because of the sheer volume and type of data we have to deal with, as people are on their phones for most of the day. And things move really fast in telcos. You need to be able to analyze things and make decisions in a very fast manner. So if you are up for a fast-paced technical challenge, a telco is definitely the place to be for data science. In another industry, for example, banking, you would have a lot less data because you would only get data when people use your app to make a transfer or call your phone number to make a complaint. And I can't talk too much about my work here, but I will go into some general use cases that there are generally for data science in telcos. So we actually have many use cases for machine learning and AI, but I'll just pick the top 3, right? So we have customer segmentation. So understanding your customers and being able to segment them into different groups based on customer segmentation models helps you target your customers better and brings in more revenue. And the picture that I've included is an example of customer segments for online clothes shopping. In online clothes shopping, you may have different customer segments like browser, fashion forward, last minute shopper, and discount lover. And the customer can belong to these segments based on their behavior from data. And based on the segmentation, you know how to best target them, right? So for example, the discount lover loves discount codes. The fashion forward person probably wants to spend when the new collections drop. And we can target customers to spend more based on their segment behavior. Another use case is customer lifetime value, or CLV. And this involves building models to predict a customer's lifetime value, which in turn aims to predict a company's net profit based on the entire future relationship with a customer. An example of this is how customers have different needs at different times in their lives. For example, in banking, maybe around mid-20s to 30s, people are getting married, starting families, and therefore getting mortgage loans out. Final use case is churn. So churn is defined as the percentage of customers who end their relationship with a company within a given period. This is bad because you lose all future lifetime value from the customer. It's also bad because generally it costs less to keep an existing customer than to have to go out and find a new customer. So for this type of use case, you try to build models that predict who will churn, so you can target the customer to stop them from leaving. So now I would like to talk about, because I can't really talk that much about work, I'm going to talk about some cool things you can do with machine learning. And some of these use cases are actually probably more deep learning, which is a subset of machine learning, as I showed you in the previous slide. But for now, we're going to keep these terms interchangeable. And the use cases I will share with you are all related to creative fields and the arts, which personally, I find very interesting to see how AI can help the arts and spur creativity. So one thing that I find fascinating is the use of machine learning with art. And we can convert images into matrices of pixels, so we can express images as numbers. In art speak, a pastiche is defined as an artistic work in a style that imitates that of another work, artist, or period. So for example, painting your cat in the style of Van Gogh would be an example of a pastiche. But we don't need to do this manually anymore because a computer can do this too, using deep learning. So style transfer is a deep learning technique used to create an image in the style of a certain artist. On the top right-hand side, you can see a few images. You see a content image, which is the image you want painted in the style of an artist. You can also see a style image, which is an image in the style of the artist. And you can take these two images, apply some maths and optimization, and you can see the results in the output image on the most right-hand side, which is the content image, which is now painted in the style of the artist. And you can see at the bottom, we have a content image that we apply style transfer to in the style of different artists and their respective output images. So you can see the same content image being transformed and painted by different artists, which I think is also really cool. Okay, so this is a bit mathematical, but we'll breeze through it. How style transfer actually works is based on maths. And the idea is that you can define two functions. One function, our content, calculates the difference between the style image and the content image in terms of the content. You have a second function, our style, which calculates the difference between the style image and the content image in terms of style. So everything really boils down to the maths. We then initialize a base input image, usually with the content image itself. And we transform this base input image over a number of iterations. And we transform this base input image so that we minimize the distance between the two equations, our content and our style. So I'm just going to run the video now to show you what this looks like. And you can see as the number of iterations increase, we can see the base image transforming more and more as the distances for the two equations become less and less. So this example video is something I programmed with a few female local artists like Nini Marini and Posy Liang for International Women's Day a few years back. And I used their paintings as a style image to transform the content image. I think it's really cool that we can program computers to turn a real photograph into an artistic piece. Okay, so I'm going to stop that. Okay. Okay, so let's move on to AI in movies and Hollywood. So now we move on from this technique being used in a single picture or a frame to a set of frames in movies. And I find this interesting. The actress Kristen Stewart recently wrote a machine learning paper on style transfer and applying this technique to one of her movies to style the movie frames to provide the effect that the movie is in the style of an impressionist painting. The paper itself is titled "Bringing Impressionism to Life with neural style transfer in Come Swim and offers a detailed case study on how to use this sort of machine learning in a Hollywood film. How cool is that? Okay. Now we go on to something a little bit different. Let me make sure my speakers are loud. Oops, not here. Okay, speakers on loud. Hold on, I won't share this yet. Okay, so now we're going to move into something a bit different, AI and music. And I guess we all know, Spotify uses AI and music to know what songs to recommend to you. And record and music companies are also involved with using algorithms to find the next breakout star. But how about musicians that compose songs just made out of AI? For music, algorithms start by analyzing data from different compositions when it creates a musical piece. Through reinforcement learning, the algorithm learns what characteristics and patterns create music that is enjoyable or mimics a certain genre. You can also find projects online that can help you generate music or rap lyrics in the style of Kanye West with AI. So let's have a listen to an example of music and rap written by FN Mecca, a new AI-powered rap artist. Okay, I hope you enjoy this. Okay, I hope you enjoyed a little taste of that. If you like it, you can look him up online. I think it's really interesting to see music that is created by an AI. And I think it's also very, very catchy. Okay, so on to the next slide. Okay, so our final bit of AI and the arts. Let's talk about artificial intelligence and creative writing. So the images attached in the slide shows a bit of Harry Potter fan fiction written by an AI. Feel free to have a read of the images. This piece is called Harry Potter and the Portrait of What Looked Like a Large Pile of Ash. And the AI created to produce this was created by Botnik Studios. The AI algorithm was trained on all of the 7 Harry Potter novels. And the result of this is a tale that has some absurd parts. So for example, you have Ron tap dancing and then eating Hermione's family, right? But it feels roughly in the style of J.K. Rowling. If you find this interesting or you really miss Harry Potter, you can Google this later. Okay, so now I'm going to go into what a student learned from an internship at UMobile. And this is based off slides that one of our most recent interns, Brianna, prepared to illustrate what she learned on an internship with UMobile. Okay, so meet our last intern, Brianna. She's from INTI International College, Subang Jaya, under collaboration of University of Wollongong, Australia. She's studying Bachelor in Computer Science, majoring in software engineering and cybersecurity. It's a very good background for us. And she's in her second year in her 4th semester. And what did she learn during her internship? Well, she was exposed to things like programming language, Python. So like I said, one of the most important things for data scientists is Python. Applications and services. So in terms of what I mentioned earlier, for visualization, she was exposed to Power BI and Google Data Studio. In terms of the tools she used Jupyter Notebook, which I mentioned earlier as well, and Jupyter Lab. Other things she was exposed to were cloud services like Google Cloud Platform, used for machine learning, and GitHub, which is where we store our code. In terms of websites, she was on the Department of Statistics Malaysia and also on Kaggle. And both of these are good for either collecting data or playing around with sample data. So one interesting thing that you guys might find interesting about her internship is she played around a lot with Google Cloud Platform, or GCP. Google Cloud is a cloud computing service that provides services like data storage, machine learning, data analysis, etc. And it's really good for machine learning use cases. And at first she started by doing everything manually and playing with the user interface. But then as she grew more confident and she explored things with the UI, she then proceeded to start programming the basic steps like creating projects, creating instances, and enabling APIs. So other things she did during her internship, like I said, Data Studio, really good visualization tools for end user. So she used it to transform data into informative and interactive visuals. She used Google BigQuery and Data Studio to create dashboards for data visualization, which could potentially be shared with our end users. I think this is the coolest part of what she did. She had to go create a pipeline, so automate data processes. And a pipe is a method used to connect components together, and data moves from one component to the next through pipes, right? So you can create a whole process, a whole pipeline. And then also from this pipeline creation, she also learned how to, kind of be self-reliant. So she learned how to sort things out like GCP permissions and how to log errors, so she could help herself debug any errors that she faced while she was playing around with the cloud services. And here is some of the feedback she gave us. So she said it was an eye-opening journey. She got to learn so many things that she never knew existed, or things that perhaps she would not have explored if she didn't come and do an internship with us. So in terms of technical skills, she definitely learned new programming languages like Python, for example. She learned a lot about using cloud services like Google Cloud Platform. And then she also learned on many different types of software and services like Power BI, Data Studio, and even the Excel add-ins. She also learned a lot about real-life work etiquette, improved on her soft skills and professional presentations, and she experienced corporate teamwork. Okay, so now we're on to like the last section of my slides, how to get started in data science. And the list here is mostly from my own experience and what I use, as well as, more than anything else, there's an infinite number of good YouTube videos and online courses you can take too. So one of the things I like to recommend is the Google Machine Learning Crash Course, right? It's a really good free introductory machine learning course with programming examples and hands-on experience with Google Colab. And there's a link there. And Google Colab is a Jupyter notebook that is serverless. It runs in the cloud and it's free of charge. The example of a Jupyter notebook I showed you just now was on Colab. And it's great because normally if you did this on your own, if you run this locally, you would have to do all kinds of things like, look at your Python version paths and everything and install a lot of tools. But Colab is a way to get started really fast and in a frictionless way with Python and with machine learning. You can also share the notebooks that you create. Just like a Google Doc, you can save it in Drive and share it with your friends. And you can also get like free GPU. Okay, other things I enjoy doing is reading Medium articles by like-minded technical people in the data industry and seeing how they approach problems. There's a lot of very good technical writers on Medium for data science. And I also like to find interesting projects on GitHub. And sometimes the Medium articles I read will have links to GitHub repositories. And I like to play around with the code repos on GitHub. And another thing is Kaggle, right? So this is pretty well known and it's good for like data modeling competitions. And Kaggle also provides a Jupyter notebook environment similar to Colab's. And I use Kaggle sometimes for downloading sample data to play around with. So I have a little 0 to hero plan here. Again, this is based on my own experience and things I did to get into data science. So first, I would say you should learn as much as you can. You can take an online course, you can watch YouTube videos, read interesting articles and blogs on Medium, learn something that you're passionate about, and then practice, right? So discuss, technical topics with friends, give technical presentations to peers, try public speaking. It's really good for you. And then apply. So this is probably the most important thing, is application, right? So find projects you like and start playing around with code. Try taking it apart, putting it back together. Play around with Google Colabs and Kaggle. You don't need to go through the whole route of installing things and running things locally. You can just get started really fast with Google Colabs and Kaggle. And then participate in hackathons, where you will build things fast and learn hacks from people in your team. I can't recommend this enough. It's a really good collaborative experience. And it's really fun to build something really fast. And then join a developer group. So there's so many these days. I mean, the two I'm mentioning are Google Developer Groups KL, Women Tech Makers KL, but there's so many. There's like PyCon, there's like JavaScript developers, regardless of whether you want to do data science or not, you should join developer groups. And join online events with like-minded folks. They used to be in person, but now everything's online, obviously. And then, if you can, find an internship where you can apply yourself and you can grow. Okay, so now I present the apprentice program at UMobile. And please follow, you can scan the QR code and please follow UMobile on LinkedIn. There are two potential tracks for this. One is for software engineering and one is for data science. So what you need is looking at the requirements, you need a degree in computer science or IT or some related and relevant degree. The apprentice program is a fixed one-year contract. And do scan the QR code and follow UMobile's LinkedIn page. If what I shared with you about Brianna's experience or anything I've shared with you today really interests you, scan the QR code, follow our LinkedIn page, as there will be major announcements for this soon. Okay. And now we're going to, were you listening? So Teresa, do you want to share? Teresa, yeah.
Yep, sharing.
Okay. So guys, join our quiz. So slido.com again, 429-958. We want to see, were you guys listening? Were you paying attention? Yeah, so scan the QR code or it's slido.com, enter the code 429-958. I see learned. Okay, cool. So I think, yeah, so this is a little quiz. We're just going to see, were you paying attention? Were you listening? Maybe what you found interesting, what you didn't. But this is going to test you a little bit on, the things I just presented. Yeah, so let's see who comes up on top. Teresa, are you ready to start?
Yep, anytime.
Okay. Yeah, why not? Let's just begin. Okay, so first question. What skill below is not needed to do data science? Is it math statistics, programming, domain knowledge, or drama? What skill below is not needed to do data science? Yes, okay. So that's great. So most of you got that right. And you know that, yes, drama is a creative field. Maybe in the future we have an AI that can, somehow do drama. And that is what we actually don't need to do data science. We actually do need math, statistics, programming, and domain knowledge, because data science is an interdisciplinary field. Okay, so let's go to the next question. What process below do data scientists tend to spend the most time doing? Data preparation, cleaning data, data wrangling, machine learning, choosing a model, deployment in ML ops, writing concept papers, or what? Oh. Did they answer this question, Teresa? Okay. Well, okay, I think maybe there was a bit of a lag. But the answer is data preparation. So 90%, like or close to that, of your time will be spent on cleaning data and data wrangling. Okay, let's move on to the next question. Okay, what does Jupyter stand for? So Jupyter Notebooks. Is it just Python era, Planet Jupyter, where machine learning was first used, Julia, Pythagoras, and random, or Julia, Python, and R? So what does Jupyter stand for in Jupyter Notebook or Jupyter Lab? Okay, so let's give them a few seconds. I think there's a bit of a lag, so we have to wait. Sorry, Teresa, can you scroll down a bit? Because I can't see the whole thing. Okay, good. So most of you got that right. It is, Jupyter is a loose acronym for Julia, Python, and R. And it's really good. It supports many programming languages. And it's very good for running Python in an interactive web application. Okay, next question. Okay, blank algorithms enable computers to learn from data without being explicitly programmed. Is it sorting? Is it machine learning? Is it selection? Or is it Euclidean? Okay, good. So 87% of you are switched on. It is machine learning algorithms. And we talked about quite a few of those just now, as well as interesting use cases with machine learning algorithms and art. Well, probably more deep learning, but you know what I mean. Okay, so let's move to the fifth question. Blank transfer is the method used for computers to make images in the style of a specific artist. Is it artistic transfer? Is it creative transfer? Is it style transfer, or is it paintbrush transfer? Okay, again, good. Most of you are switched on. As I said, it's style transfer. And yeah, I showed you guys a video. It's pretty cool. The more iterations you run, the more the image evolves over time as the distances are minimized. Okay, so let's go to the sixth question. What is the name of the AI rap artist we listened to in the talk? I played you about 20 seconds. R2D2, DJ AI, FN Mika, or Machine Musica? Okay, this one was a bit of a hard question, I guess, because yeah. Okay, this one is definitely not general knowledge. You definitely do have to be switched on to know this. So yes, it was FN Mika. And if you really enjoyed that, then you know, go find some samples of his music after this. I personally find it really catchy, and he's really big on TikTok. Okay, so the final question. Who wrote the algorithm that wrote Harry Potter and the Portrait of What Looked Like a Large Pile of Ash? Was it Botanic Studios? Was it Artificial Labs? Was it Machina Labs? Or was it AI Industries? And good, okay, most of you got that right. 64% got it correct as Botanic Studios. And if you enjoyed that little excerpt, that little photograph excerpt that I shared, you know, do Google search. I think there's like a whole 7 pages of that, you know, if you miss Harry Potter and, you know, J.K. Rowling. Okay, so who's the best? Okay, congratulations, Danny, Siti Nur Aisha, Hilmi, Rachel, and Jamian. Congrats, you guys did very well. Okay, so now, are we out of time or are we doing Q&A?
Dania, sorry.
We still have like 10 minutes for Q&A session.
Okay, so does someone want to ask me the questions and I will respond?
All right, so we have the, okay, hi. So we have a question asked by Shiun Ho. What is your advice for people from different backgrounds to join data analyst role? And how do they make themselves as competitive as people who took data analysts relevant in their studies?
Okay, so this is my personal opinion. And as I shared with you guys, data science back in the day didn't really exist, right? And I personally came from an engineering background. So for me is what I like to see is that, you know maths, programming. So how you want to show that, whether you're just from computer science or IT, whether you did engineering or science or something related where you were exposed to programming, right? And for me, you don't have, like, your degree is just, what you apply yourself to. But if you are able to show me, like, this is a model I built, this is some coding I did, this is some dashboard I did, like, I think that's pretty relevant. Because a lot of data science is self-taught. A lot of it is based on you keeping up with the trends and the technology, right? So I think that's a way to differentiate yourself. You may not come from the typical like IT background. You may come from something related, but I do expect you to have strong programming and strong maths. And if you can show or demo me something that illustrates that you are passionate, you have spent time learning, understanding, and building things, that's what I like to see, and that is what I find valuable. Yeah.
All right. Thank you. So we have another question by Fakiha Shazwani. So what is the language of programming you advise us to master if we want to take data science?
Okay. I mean, I mentioned quite a few, right? So number one is definitely Python. Python is the language of data science. It's where all the important machine libraries are in. So Python is definitely, for me, number one. After Python, I would go for, a database programming language like SQL, because a lot of companies, they're based on SQL, so you should know how to be able to query data from the systems. And then the third thing I would go for is, shell scripting, just so you know your way around a computer, know how to run things on server. So those are the three that I would recommend. Number one is definitely Python, and definitely familiarity with Jupyter notebooks, and machine learning libraries. If you want to do data science, you should know about scikit-learn, you should know pandas, you should know TensorFlow by Google. Yeah, this is what I would say for programming languages for data science. Yeah.
All right. Okay, then for the third question, we have Lashwini Villau. What motivates you to be a data scientist?
I think that, if what motivates me is that I'm naturally curious, and there's so much to learn. Things change all the time, especially with technology, right? You may write code based on a library, right? And then like 6 months down the line, that library is deprecated and you have to adapt, right? Or things change and your function is no longer relevant, you have to adapt. And there's so many breakthroughs all the time with new technologies and data science. So that is also what I find really interesting. Another thing that I find interesting, and that's just mostly from being at a telco, right, is that, we're in like kind of one of the weirdest points of history where we have a big COVID crisis, right? And, telcos are still getting a lot of data because people are on their phones. So for me, this type of stuff is what drives me, what makes it really interesting. Number one is being on the bleeding edge of technology, right? And number two is being at a telco where everything is so dynamic and there's always things to learn. And I'm naturally curious. Yeah.
That's very nice. Thank you. So we have one of the audience members, Amaline. So she recently graduated in BSc Industrial Mathematics from UTM, and she would like to know if there's any position for entry level in data science or analyst. She has technical skills in Python, SPSS, Excel, and Power BI.
Power BI, yeah.
Power BI, yeah.
Yeah, that's pretty good. So what I would say, right? Yeah, math is great for sure, as well as Python programming. So I mentioned the U Mobile Apprentice program. So I would recommend you join the LinkedIn. There's going to be some announcements in the future by HR. So this is for data science and IT. And it's a 1-year program, a 1-year fixed term contract, right, for people who just finished uni, like her. So that's where I would advise you to start. Yeah.
All right, so to the audience,
very valuable.
Yes, to the audience, make sure to stay tuned with UMobile's Apprentice program. So let's wrap up this Q&A session with the final question from Siti Nur Sabrina. Can you tell us about a data project you've worked on where you encountered a challenging program, and how did you respond to it?
Okay, I don't think I can talk too much in terms of my work, but I will give a general example. So, sometimes, like what I said, you have to be very self-reliant, right? You can't depend on people. You have to be able to execute and get things yourself. And that's why you have to know a huge amount of programming languages, because there's many ways to do things, right? But not every way is the best way. Sometimes you need options because you need to find the best way. So one thing that, I have found challenging is a project that it launched, but then afterwards, we had to collect data from it, and we had to collect the data really fast. So what we had to do with that was we had to adapt really fast, find the data, mine the logs from the system to find the data, and essentially create our own database from the logs in a very, very fast period of time. So that for me is one of the more challenging projects that I've worked on. Yeah.
All right, thank you so much. So that marks the end of our session for today. So thank you so much, Kamra, for such an insightful session. I hope everyone enjoyed this session and learned new things about the sexy job of the 21st century data scientist. Be sure to visit UMobile's virtual booth and follow UMobile on LinkedIn account. And don't forget to stay tuned with the announcement this week. Also, vote them as Malaysia's most preferred employers for the Grand Brand Awards. You may place your vote at their virtual booth and also the Brand Awards websites. To the audience members that had their questions answered on the chat box, Team Graduan will be in touch with you via email for your Shopee vouchers. And we'll see you at the next session, and thank you.
Thank you so much, guys. Bye.